Hi everyone, in this video we're going to go through the general solution of trig equations. So you've probably seen these before because often on our calculator we forget to restrict our domain if we're solving a trig equation, and we come up with this sort of syntax. So you're like, oh, I need to restrict my domain. So you don't usually think too much about what is actually happening here. You just go straight to, oh, I forgot to restrict my domain, which is fine because often we come across questions where the domain is restricted, because with sine, cos, and tan graphs, you can have infinite solutions. And this is basically what we're doing here with the general solution, because you can't write every single solution because there's infinite solutions. So what we do is we say, all right, depending on whether it's sine, cos, or tan. So I'll just get my highlighter up here. So you can see here we've got cos x equals a, tan x equals a, and sine x equals a. So what we do is, with our general solution, as long as we can identify what a is, we just substitute that into our equation and substitute in different values of n. All right, so where n is an element of z. Now, you may have recalled when we did the video for 6j, the first video for 6j, that z is an integer. All right, it doesn't have to be positive. Okay, sorry, it can be positive, it can be negative, or it can be 0. Z is just an integer. So basically, we just substitute in different values of n if we need to. Okay, so it's one way of actually finding your solutions, is to find the general solution and then substitute in different values of n to get your other solutions. So instead of using things like the unit circle like we had been, okay, you could just use your general solution and substitute in values for n. So do notice that they change slightly. So each one is different, but you'll notice your value of a always substitutes in. So for cos, we've got 2n pi plus minus. For tan, we've got n pi plus. And for sine, we've got 2n pi plus. And that all relates to the unit circle and where sine, cos, and tan are positive and negative, etc. Now, on your calculator, which is what you've seen before, we basically have this part here. All right, and you'll notice that that is the same as the n. Okay, so this one here, what am I doing? So your value of, so we're doing cos. All right, so inverse cos of 0.5 is pi on 3. So you can see the plus and the minus, pi on 3. And then we've got the 2 pi. And just for this part here, where const is just constant, we're just substituting in different values of 1. But it's easy to do on your calculator. You're just doing solve and then you come up with this solution. So all you need to do on your, if you had an exam, you could just write 2 pi plus or minus n. Oops, what am I doing? No, don't write that. That's my fault, I wasn't concentrating. 2 pi n plus or minus pi on 3. I just put that plus and minus in the wrong spot. But then you would also have to say where n is an element of z. Okay, so with your solution, you do need to write where n is an element of z. If you've got your solution in terms of n, you can use any other letter. If you use k, then you just got to say where k is an element of z, whatever. But you do need to put the where n is an element of z on there, or k is an element of z whatever. You can't leave it just like this. You need to say what n represents, and it represents an integer. And z, you have letters for positive integers, negative integers, but z is all integers, including 0. Okay, so for question 1, we've got different values of n. And for the first one, we've got 2 causes. So 1a, so we're going to have n equals 1. So we've got 2 pi plus or minus. Now cos of 1, what is that, 0? So this is going to be 2 pi. Then when n equals 2, we're going to have 2 times 2 pi plus or minus 0. So we're going to have 4 pi. And then n equals negative 2. So this time we're going to have negative 2 times 2 pi plus or minus 0 again, because we're doing cos of 1, which is 0, inverse cos of 1, sorry. So that's going to be negative 4 pi. So basically it's showing all the different solutions for that. All right, now if you think about the equation, it would be cos x equals 1, which we know on the unit circle is here. So it is at 2 pi, 4 pi, negative 4 pi. All right, let's move on to B. I'm going to do that in a different color. All right, so we're going to keep n the same. Okay, so n equals 1. We're going to have 2 pi plus or minus. Now, inverse cos of negative a half. Oh, God, I'm just going to cheat and do it on my calculator. I'm sorry, I just don't have the energy to go and check right now, but you should know what that is. Oh, what the exact value, thank you. 2 pi on 3. So we've got to have 2 pi plus 2 pi on 3. So if we have the same denominators, that's better. So 2 pi is the same as 6 pi on 3 plus or minus 2 pi on 3. So what's that? 8 pi on 3 and 4 pi on 3. All right, and I'm just going to do one more just to, because I'm a little bit exhausted from doing these. All right, so this time we've got n equals 2, so we're going to have 4 pi plus or minus 2 pi on 3. So just to have the same denominator, 4 pi can be rewritten as 12 pi on 3. So we're going to have, we'll subtract first, so 10 pi on 3. And the other one's going to be 14 pi on 3. All right, for question 2, we're given the equation. So all we need to do is identify what A is. So for question 2A, A is equal to root 3 on 2. So our general solution, I might do that in a different color, is x equals, scroll up, 2n pi plus or minus cos root 3 on 2. All right, sorry girls, I had a break, had some dumplings, so hopefully there's some continuity in what I'm doing. Okay, so x equals 2n pi plus or minus cos root 3 on 2. So, oops, I forgot that -1. So we do need the exact value of that. I hate scrolling up and down, but my exact values are here, so it's not too bad. Cos root 3 on 2 pi on 6. Oh, where are we? So it's going to be x equals 2n pi plus or minus pi on 6. And you do have to say where n is an element of z. All right, question B is slightly different because we do have that 3x. So that's, I hate it when I go to use a highlighter and it just uses the pen. All right, so it does make things a little bit different. So let's do that one. Now I know I haven't left much room. I don't know why I did that. Probably I was thinking I could do them all on the calculator. All right, so 2 sine 3x equals root 3. So a is equal to, so I got to bring that 2 over, so root 3 on 2. So my solution is going to be, for sine, is x equals, now I can never remember, for sine 2n pi plus. All right, so inverse sine of root 3 on 2. Now, if inverse cos of root 3 on 2 is pi on 6, then inverse sine of root 3 on 2 is pi on 3. So we've got 3, don't forget that 3x there. So 3x equals 2n pi plus pi on 3. Now, we do need to solve for x. So we've got to divide everything by 3. All right, so dividing everything by 3, and that gives us x equals 2n pi on 3 plus pi on 9. Now, what I didn't realize before, with sine, we actually do have 2 solutions. So the other one is here. All right, so 2n plus 1 pi minus that. So I might just write that down before I scroll. So 2n plus 1 pi minus. All right, so there's one solution. So I'm going to keep that there. Oh, highlighter works when you don't want it to work. Okay. And then our other one, we've got 3x equals, now where are you? 2n plus 1 pi minus pi on 3. So we're going to divide everything by 3. So we've got x equals 2n plus 1 pi 3 minus pi on 9. So I'll highlight that as well. And don't forget that n is an element of z. Now you could expand this if you like, and you'll notice in the solutions it's been expanded, but leaving it like that is fine. I'm just going to leave it like that to keep this video short. All right, question 3, find the first 2 positive solutions of each of the following equations. All right, I'm just going to get you started on the first one. So we've got sine x equals 0.5. So our solution's going to be x equals 2n, I'm looking over the right side of the page, plus inverse sine of 0.5. And that is, what is 0.5? terrible with my exact values. I hate scrolling. It just takes up so much. All right, where are you? Sine 30, so pi on 6. And then the other solution is x equals, I'm going to just put a little bracket box around that. X equals 2n plus 1. No, 2n plus 1, yep. Pi plus, sorry, that should be a minus pi on 6. Where n is an element of z. Now, the question is asking find two positive solutions. So we're going to let n equal 1. All right, so when n equals 1, I don't know whether you can hear that. Doesn't sound promising. Actually, we'll do n equals 0 first. All right, I just wrote it down because the dinging sound would annoy you. So I did n equals 0 and we get x equals pi on 6. So that's substituting it into the first solution, x equals 2n pi. Now you could substitute it in the second one, but you're going to get a negative answer. All right, so when n equals 1, if I was to substitute it into the first one, I'm going to get an answer, but it's probably not going to be one of the first positive solutions. Okay, so pi on 6 is clearly our first one. To get your second one, we've got to let n equal negative 1. And I'm going to substitute that into the second equation. So when I substitute it into the second solution, I get negative 2 plus 1, which is 1 pi minus pi on 6. Now, when you think of the unit circle, here I am trying to get away with it. Wonder if I can do it. Let's see. Is it going to let me do it? If you think of the unit circle, all right, our solutions, we're looking at signs, so we're positive here and here. So our first solution is going to be 0 plus pi on 6 in this quadrant, and our next one's going to be pi minus pi on 6. So you can see how you can use your general solution to get your actual solutions, right? You're just substituting in different values of n. I can substitute 0 into both of them as well. I can substitute 1 into both of them. I can substitute negative 1 into both of them. Okay, but the question did ask for the first two positive solutions. Okay, so the first two positive solutions, pi on 6, which is in the first quadrant, and then pi minus pi on 6, which is 5 pi on 6 in that second quadrant. This other solution I found, 2 pi plus pi on 6, is actually your third solution going around the unit circle again to 2 pi. All right, so we're in that first quadrant, plus pi on 6, and you can kind of see what is happening with that pattern. All right. Oh. Now, I don't know how far we're going to get without the computer crashing on me, so let's have a look. Question 6, find the general solution for each of the following. So this time we have obviously brackets. So we can just do it the same way as before. But this time we're going to have, instead of x equals, we're going to have 2x plus pi on 3. Oh, I can't believe it's stopped doing that. Now, what was cos 0.5? I did it before, but I'm too scared to scroll up. So I'll just quickly do it on my calculator. All right, so we've got 2x plus pi on 3. Now, inverse cos of a half is pi on 3. Now, your solution's going to be, instead of x equals, we're going to have 2x plus pi on 3 is, what is it, 2 pi n plus or minus, inverse cos of a half is pi on 3. And now we just do, we don't have to do anything else. Oh, no, we do, since we don't have x equal x on its own yet. All right, so let's divide both sides by 2 first. So that cancels out, so we're left with x plus pi on 3 equals 2 pi, oops, those 2's cancel out, so that's good. All right, so this 2 cancels with this 2, so we've got pi n plus or minus pi on 6. And now we're going to have to subtract pi on 3 from both sides. So that goes, so x is equal to pi n. So we'll do the plus first, so plus pi on 6 minus, and then I'll write the pi, plus pi on 6. Pi on 3 is the same as 2 pi on 6. So that is x equals, now I should write n pi, not pi n. N pi, so what is that? Negative pi on 6. And then the other solution is pi n, or n pi, minus pi on 6 minus pi on 3, which is the same as 2 pi on 6. Probably should have written that. So x is equal to n pi minus 3 pi on 6, which is pi on 2. So the solutions are going to be x equals n pi minus pi on 6 and x equals n pi minus pi on 2, where n is an element of z. All right, just because we haven't done any on the calculator, I'm going to do B and C on the calculator. So just a solve. Now, these types of questions you should only see on exam 2 anyway, so don't be too concerned about having to memorize them. X plus pi on 4. Just make sure I've got enough brackets. Equals 2 root 3. And we're solving for x, so comma x. And remember, we don't restrict our domain. So we end up with this sort of solution. So all you need to do is replace that const n. Go back here. X equals keeps disappearing on me. Pi n over 2. Now it doesn't matter if you write n pi or pi n, minus pi on 12. And just remember, you do have to write where n is an element of z. So that's all you need to do on your calculator. You just replace that constant with n. The number in the brackets just represents what constant it is. So I think we had one where we had 2 solutions. Oh, probably can't find it now. With the last one, we might have 2 solutions. So let's do that one. We'll do sine, that last one. All right, so we've got solve 2 sine x plus pi on 3 equals -1. Don't need to restrict the domain. So you can see here we've got constant 1 and constant 2. All right, so that just means you can just separate them. So x equals, calculator, 2 pi n minus pi on 2, 2 pi n minus pi on 2, or x equals 2 pi n plus 5 pi on 6. And don't forget the n is an element of z. Okay, so just doing your solutions that way, and I just realized that's not question B, it is question, oh no, that was B, and that one was C. B, C. All right, girls, I think I'm a bit tired, so probably a good idea to stop now before I make any more errors. I'll see you later. Bye.